Welcome to The Explainer. Today, we are unpacking a breakthrough that honestly sounds a little bit like science fiction, but it's totally grounded in proven materials science. We're going to explore how microscopic chemical reactions translate directly into undeniable, hard financial returns. If you're at all passionate about the future of green energy, modern architecture, or, just making heavy infrastructure vastly more efficient, you're absolutely going to find this fascinating. Let's get right into it. Okay, let's dive into this. Ask yourself, what if our buildings and solar panels could just clean themselves? We literally spend billions globally fighting this never-ending war against dust, soot, agricultural dirt, and corrosive coastal salt. It's a massive, hidden cost, just a constant operational drain on commercial real estate and solar farms alike. But what if the infrastructure itself could actively fight back against those elements? Well, this brings us to TS1 by NanoZ Coating Limited. Now, this isn't just a concept. It's a fully realized joint technological development between Israel and Japan, and it's manufactured right at the NanoZ facility in Yavne, Israel. They've effectively cracked the code on how to make surfaces self-sanitizing. Here is our quick agenda for today. First, we'll meet NanoZ's TS1. Second, we'll look at the science of self-cleaning. Third, we'll cover transforming solar and glass. And finally, number 4, the financial ROI model. Section 1, meet NanoZ's TS1, the active coating. So what you really need to know right off the bat is that TS1 is a transparent photocatalytic coating, and it is powered entirely by the sun. This is absolutely crucial to understand. This isn't just some passive chemical wash, right? It's not a temporary wax that you spray on and then just forget about until it washes away in the rain. No, it's an active nano coating. It literally uses ambient light, specifically UV light, to continuously sanitize, clean, and purify the surfaces it's applied to. It basically turns a piece of glass into an active engine. Section 2, the science of self-cleaning. Let's look under the microscope. If you've been following photocatalytic coatings for a while, you know the Achilles heel has always been the binder. The glue that actually holds the coating to the glass. Traditional organic binders essentially eat themselves. The active oxygen they generate to clean the glass actually ends up destroying their own organic binder. So, in like 2 or 3 years, they just peel right off and fail. But the real breakthrough with TS1, which was developed alongside their Japanese partners, is the use of a 100% inorganic binder. This creates a permanent chemical bond with the glass that is completely unaffected by the active oxygen it produces. It doesn't eat itself. Instead, it creates this unbreakable bond that lasts for well over a decade. And because of that incredible inorganic binder, TS1 delivers some seriously impressive physical specs. We're looking at a 100% pure titanium dioxide, or TiO2 layer, and the resulting surface achieves a 7H pencil hardness. In practical terms, that means it's exceptionally resistant to wear, tear, and even harsh blowing sand in desert environments. Plus, as we just touched on, it secures a 10+ year average service life. So how does it actually clean anything? Well, it relies on 2 incredibly cool scientific principles working perfectly in tandem. Step 1 is photocatalysis. When UV light hits those TiO2 particles, it generates active oxygen. This oxygen acts like a microscopic incinerator. It literally burns and decomposes organic threats like pollen, soot, and bird droppings, turning them into a harmless, fine dust. Then, step 2 kicks in, superhydrophilicity. When water, whether that's rain or just morning dew, hits the panel, it doesn't beat up. Instead, it spreads out into this perfectly uniform thin layer that sweeps right under that decomposed fine dust and any dissolved salts, washing it all away cleanly without leaving a single streak behind. It's really cool when you compare it. Notice how on a standard hydrophobic surface, water naturally beads up into little droplets, and those droplets act like tiny magnifying glasses, basically burning the panel in the sun, and then they leave these distinct dirt rings when they finally evaporate. But with the super hydrophilic surface of TS1, the water contact angle is incredibly low. The water just sheets across the entire surface. It effectively acts as an automatic squeegee that grabs all the contaminants and just slides them right off the edge. Section 3, transforming solar and glass, real-world applications. As you can imagine, the primary markets for TS1 are massive, spanning heavy architectural and energy infrastructure. Commercial solar panels are obviously a huge use case, but this is also purpose-designed for high-rise building glass facades, especially those tricky ones with combined aluminum and glass cladding, as well as expansive office buildings, shopping malls, and airports. Basically, anywhere there is vast, hard-to-clean glass, TS1 is a perfect fit. And there's a really fascinating protective benefit here, particularly for infrastructure situated on the coast. In corrosive marine environments, salt buildup is just an absolute killer. It destroys the aluminum frames of solar panels and windows over time, but because TS1's super hydrophilic sheeting action constantly washes those salt particles away, it actively protects the aluminum frame. The data actually estimates this can extend a solar panel's lifespan by up to 25% in these harsh, salty environments. That is some serious asset protection. Section 4, the financial ROI model. Let's look at the C-Suite executive report. The sources provide us with a highly detailed ROI model based on a 10-megawatt reference project over in Israel. This specific project covers 50,000 square meters of net panel area. Because NanoZ uses a direct manufacturer model, meaning direct supply straight from their Yavne factory with absolutely no middleman distributor markups, the pricing is highly optimized. The all-in capital expenditure, or CapEx, which includes the raw material, the logistics, and the local contractor application, comes out to just $7.70 per square meter. So for a massive 10-megawatt farm, the total initial investment is right around $385,000. Now, let's look at where the savings actually begin. In a dusty environment like Israel, manual washing is an oppressive operational expense, or OPEX. And frankly, it's just a terrible job. No one wants to be out there scrubbing panels in the blazing desert heat. For a 10-megawatt farm, you're typically spending about $60,000 a year just on labor, water, and logistics for cleaning alone. But because TS1 actively breaks down the dirt and uses the morning dew and rain to sheet it away, the frequency of required manual washes is slashed by more than half. The new OPEX drops to roughly $22,500. That's an immediate direct savings of $37,500 every single year, going right back into the budget. But wait, it actually gets better. It's not just about saving money, it's about making more of it. Because the panels are continuously shedding dust and soot every single day, instead of waiting weeks for a manual wash, they maintain a much higher average efficiency. The data shows an active yield optimization of at least 5%. For our 10-megawatt farm, that 5% bump in energy production translates to an additional $48,125 in gross annual revenue. You are literally generating more power from the exact same amount of sun. So the crucial point really is this number right here, $85,625. This represents the total combined annual financial benefit. It's the sum of the $37,500 saved in washing costs, plus the $48,125 gained in new energy yields. Every single year, TS1 is generating over $85,000 of positive financial momentum for this specific project. Let's plot that out over a 10-year cash flow table. Because remember, that inorganic binder guarantees this coating lasts for a full decade. In year 0, we have our $385,000 CapEx investment. As we move down the timeline, capturing that $85,625 benefit annually, you can see the net financial balance shrinking rapidly. By year 4, the deficit is almost entirely gone. At year 4.4, we officially hit our break-even point. And since the coating keeps working all the way through year 10, the project generates a massive positive net profit of over $471,000 by the end of the decade. I really want to emphasize this milestone for a second, 4.4 years. In the world of heavy infrastructure and commercial energy, a payback period of under 4.5 years is extraordinarily fast. Everything after that point is pure, unadulterated profit generated by an invisible, self-cleaning nanolayer. And that brings us to the ultimate metric of success, 222%. Over that 10-year lifespan, the total return on investment is highly impressive. The client is looking at a 2.22 cash-on-cash multiple. You put $1 in, and over 10 years, the sun and this brilliant bit of chemistry hand you $2.22 right back. This quote from the executive report beautifully summarizes the entire value proposition of TS1. It truly changes the economic equation. It allows asset managers to take an oppressive, fixed OPEX, the endless treadmill of paying to wash glass, and transform it into a smart, one-time CapEx investment that yields deep returns for over a decade. And it's all made possible by solving that organic binder problem that plagued older technologies. Which leaves us with this final provocative thought to ponder. If a single application of this Israeli-Japanese nanocoating can turn a daily maintenance liability into a massive, decade-long profit center, can we really afford to leave our green energy and modern architecture completely naked to the elements? The science is here, the math is proven, and the future looks a whole lot cleaner. Thank you so much for joining me on this explainer. Keep learning, keep asking questions, and I'll catch you next time.